In this video, we are going to define the functional group, state and identify the functional groups in a compound, define and explain the general characteristics of homologous series. There are so many known organic compounds in existence, so it would be very challenging to memorize the chemical reaction for each one compound. Fortunately, molecules with similar functional groups tend to undergo similar reactions. A functional group is defined as an atom or group of atoms within a molecule that has similar chemical properties whenever it appears in various compounds. Even if other parts of the molecules are quite different, certain functional groups tend to react in certain ways. The following is a list of common functional groups. Alkane sequence form the inner framework of most organic compounds. For these reasons, alkanes are not formally considered as a functional group. Alkenes consist of a carbon-carbon double bond, while alkyne consists of carbon-carbon triple bonds. Alkene, alkene, and alkyne are all classified as hydrocarbons because they are composed of carbon and hydrogens only. The aromatic compound is represented by the benzene ring. When the carbon of alkane is bonded to one or more halogens, the compound is referred as an alkyl halide. In the alcohol, a carbon is single bonded to an hydroxyl group, which is the OH group. Phenol has hydroxyl group directly attached to one of the carbons of the aromatic ring. So in phenol, it has two functional groups, which is the hydroxyl group and aromatic ring. In ether, or known as alkoxy group, a central oxygen is bonded to two carbons. Aldehyde and ketones both have same functional group, which is the carbonyl group, the C-double-bond-O group. But in aldehyde, the one side of the carbonyl group has the hydrogen atom, while the other side has the carbon atoms except for the methanol. In ketone, the both sides of the carbonyl group got carbon atoms. In carboxylic acid, it has the C-double-bond-O-OH group, which is called as carboxy group. In ester, it has the C-double-bond-O-OC group, which is called as carboalkoxy or ester group. A group with C-double-bond-OCl is called as an acid chloride. An anhydride consists of C-double-bond-O-C-double-bond-O group, while an amide consists of C-double-bond-O-N group. An amine consists of the NH2 group, and it is called as amino group, while the nitrile consists of C-triple-bond-N, it is called as cyano group. So let's have a look at on how to identify the functional group in the molecules. So first, let's circle the functional group that we spotted. Okay, so here we have the C-double-bond-O-OH. So this is the carboxyl group. Okay, so remember, it is not a carboxylic acid. Carboxylic acid is the class of compound. The carboxyl group is its functional group. Okay, so here we have C-double-bond-O-O, C-double-bond-O. So this is an anhydride. Okay, so we have anhydride here. And then here we have C-double-bond-O-N, right? So here is the amide or carboxamide. Okay, so this is an hydroxyl group. Okay, so we have an hydroxyl group. Okay, so this is an amino group, right? Amino group. And then here we have CC double bond. So the functional group is carbon-carbon double bond, right? Carbon-carbon double bond. Okay, and then here we have the C-double-bond-O-O-C. So this is an ester, right? Or carboalkoxy group. Homologous series is a series of compounds where each member differs from the next member by a constant CH2 units. The characteristic of the homologous series is it must have a general formula. The successive members differs only by the CH2 group. Its physical properties change gradually. It has a similar chemical properties and it may be prepared by similar chemical method. This is the list of general formula of some class of compound. The R here normally refer to the alkyl group. For a cyclic compound, it will be reduced by the two hydrogen atoms. When an alkane reduces one hydrogen atom, it will become an alkyl group. For example, here if we have a methane with CH4, the alkyl group that comes from methane is a methyl. So it will become CH3. So it will reduce one hydrogen atoms. For ethane, okay, so here we have C2H6. Okay, so it is an ethane. Alright, so when it reduces one hydrogen, it will become an ethyl. Right, so it will become CH2CH3. For propane, it will become a propyl. Butane will become a butyl, and pentane will become a pentyl. Alkane and cycloalkane both are from the same class but different homologous series because it has different general formula. For the cycloalkane, it will reduce two hydrogen atoms from the alkane. Okay, so for the cycloalkane, we are going to start with three carbons. Okay, so it must have more or equals to three carbons, right? So for the three carbon in cycloalkane, we call it as cyclopropane, right? So this is the general formula for the cyclopropane, which is C3H6, and in the skeletal form, we can see that it has a triangle shape. For butane, it will become a cyclobutane with four carbons, so it will give us a square shape. For pentane, cyclopentane, so it will give us a pentagon shape. Alkene and cycloalkene are from the same class but different homologous series due to the different general formula. For alkene, it must consist of two or more carbon atoms because it must include with the carbon-carbon double bond. But for cycloalkene, it must consist of three or more carbon atoms. For the three carbon of the cycloalkene, it is called as cyclopropene. Right? So in this cyclopropene, it have one carbon-carbon double bond. For butene, it is a cyclobutene, right? So here we have one carbon-carbon double bond, and in pentene, it will become a cyclopentene with one carbon-carbon double bond.